Hey guys, how are you? Welcome to my talk. I'm going to be talking about eth-hooks and scaffold-eth-typescript. Hopefully you guys have already seen Austin Griffith's um, video on scaffold-eth. He's the grandfather of this whole thing, and he's got this amazing energy, and he's already showed you guys how to use scaffold-eth, which is a great scaffolding and prototyping system for Solidity and React. So I'm going to go over some of the libraries that scaffold-eth uses. One of them is eth-hooks, the other one's eth-components, and how that will make your developer life a lot easier and what you guys can do with that. And in addition to that, I'm going to go over scaffold-eth-typescript. It's different from scaffold-eth. It's obviously made with TypeScript, but it's got a few other features and developer improvements. So there are some changes to it. So let's get started. To go over the topics real quick, I'm going to go over what eth-hooks and the features and details are of eth-hooks. You can use this in any React project that you want to do. We do have a website for the documents that we're slowly building out, and it's going to have guides from basics to more advanced, and we're slowly building it out over the next month, and there's some in there already. And after that, I'm going to go over the examples of using hooks and then overview of scaffold-eth-typescript. And then we'll dive into the details of how to use contexts. We have ethersappcontext and also contract context with eth-hooks. And we'll talk about how it works with typed contracts. And after that, we'll go over how to use scaffold-eth-typescript to do rapid Solidity prototyping and some of the differences between scaffold-eth and scaffold-eth-typescript, which is the biggest difference is Vite and how it uses what the bundler is. Okay, so all right, so to go over some of the principles of eth-hooks, which scaffold-eth and scaffold-eth-typescript uses, is we're on iteration number 4, so version 4. It's a library that lets you talk to the Ethereum network, and it provides you a lot of utility and different ways to do it. And the first important principle that we have is flexibility and how you want to update. So you can use polling, or you can use updates on blocks. Say you want to update every 10 blocks or every block, just whatever you need to do to talk to the network. We want to give you that flexibility because it adds to a cost if you're doing a production app, or maybe you want to talk to something very quickly, or maybe it's a network that updates very often, so you don't want to talk to it every block. So this kind of gives you all that optionality. The second is ease of use. There is a context for the ethers provider, and this context can be accessed anywhere in your app. And I'm going to show you examples of that. That really, really makes it easy. You don't have to do any prop drilling in React apps, and prop drilling is basically passing around the variable all over your app. And in addition, if you want to say the user is logged into Matic, but you need to get their ENS name, you can also pass in a provider directly to some of these hooks, so that you have multiple options. And then the last is it's using React query under the hood to do easy caching. You don't have to worry about how many times you call the network, as long as the variables you pass in are the same. You don't have to really care about how you optimize RPC calls. So this is going to do that for you. We really wanted to make sure that we are abstracting away some of this complexity of talking to Ethereum. It's all async, and it's kind of hard to think about. It's not as easy or fast as Web2. So some of these features will actually, especially the caching, will actually make life a lot easier. The last thing that's different than eth-hooks v4 is it works with type contracts. It really helps you make type contracts. I'm going to show you examples of how this is done. And type contracts are really important in my mind because it helps you not make any mistakes while you're calling Solidity contracts. We're dealing with people's funds, money, and their possessions. So we want to make sure we catch as many errors in in compile time as possible. And we don't want to do that in runtime. So this is the biggest reason why type contracts are very, very valuable. So to go into some more details, we have an ethersappcontext, and this provides you an app-like provider with context. So it's very easy. The complexity is hidden. And I'm going to show you a little bit of code for that. So it's super easy to use. You just have to wrap your main app with ethersappcontext. I'm going to zoom in just so that it's a little easier for you guys to see. And later, I'll also talk about contracts-app-context, which lets you access your contract data anywhere in your app as well. And if you want to use it anywhere in your app, basically, you're just calling a hook and getting the context and using it. And we also allow alternate contexts using Web3 React. And the library automatically hooks into Web3 modals. So you get a modal so that the users can access, users have a good user experience. So I'm going to show you an example. This is a scaffold-eth-typescript, and it automatically has a provider that connects it to the Web3 modal. So you don't have to write the code to set up Web3 modal and show the users this modal. It's done by the library. It makes life a lot easier. You just have to pass in the right Web3 config and tell it that you want to use Wallet Connect or Portis or whatever you want. And as an override, we also let you pass in whatever provider you want. Say you just have a hard-coded static provider that can be passed in, and it's easy to have that flexibility as well. The next part I want to talk about is cache. So all the hook results are cached. So this prevents a big problem that every developer, especially new developers in Solidity, have is repeated network calls or use effect that's repeatedly calling the Ethereum network and racking up the bill. So this is going to help you by abstracting away these calls, and you will hit your cache, or your users who are using your app will hit your cache first until the cache is invalidated, and then actually hit the Ethereum network. So it makes it more responsive, faster, and makes it a lot more efficient. You don't need to pass in variables. The hooks anywhere in the app will automatically use the cache. It's using React Query under the hood. And whenever the network or signer change, it automatically invalidates the cache, and you don't have to worry about that either. The last big part is updates. All hooks have the option on how to update. They're going to be updated every block by default, but you can set it to update every 10 blocks, 100 blocks. That's an option. You can tell it to update by polling. That's an option. Or other options that the React Query gives you, say, example, refreshing on window, focus, and a few other things are also available. And there's also an option to update manually, because the signature allows you the result and updater, and additionally also gives you access to the status of the RPC call. So say you're waiting for the data from the Ethereum network, and you can show a loading animation, for example, based on that status. The last part is a contract context. So you can load contracts with scaffold-eth and eth-hooks before in any way. You can load hard hat contacts. You can automatically load external contracts, and they're all typed. And using that, we provide you hooks to easily call and use a contract. So that is a quick overview of eth-hooks features and details. So example of how to use a hook. I've already showed you guys how to wrap your ethersappcontext. Now I'm going to show you that once you get this context by using this ethers-context hook, you can just use balance, pass in any account that you want, and get your local balance or updater, or the status of actually getting the balance. Another example is you can change the update interval. So in this one, in the second call, we're actually passing in, we want to update every 10 blocks. So that's a really easy example of how you don't have to update every block. And then there's also an example of how to do polling and how to update on window focus. So these are examples of how to update in different methods. And the last one is an override. So say the user signed into Matic, but you want to get the ENS for the user. So what's happening here is we have the mainnet provider. We're getting a wrapper by using this hook from eth-hooks. And that will give you this adapter, which is a wrapper variable. And you're going to pass that into use balance and get the balance of this user. Get the balance of this account on mainnet. So you're actually passing in an adapter directly to the hook, and you don't have to use the context if you don't want to. Okay, so next, I'm going to quickly go over scaffold-eth. So I have Solidity. I have Visual Code open here, and what scaffold-eth is this template that really gets you started in using React and get you started in developing for the Ethereum network. There's 4 main folders in the packages folder, and the first one is hard hat. This is a place where you can put your contracts for easy development. So I have this deploy script that deploys this contract called your contract. And it is, that's a contract I have now. And I also have in the Byte app TS file a React app. And this is going to be your template to rapidly develop for a UI for your Solidity contracts. And how it works is that I'm going to start this to show you guys. So how it works is that it automatically gives you this application. There are no contracts loaded now, but we're going to load a contract. So we're going to connect to, I think, all right, so we're connected to localhost. And I'm going to set the environment. So this app comes with the environment variable, and you can tell it whatever network you want to connect to. So I'm going to connect it to localhost. I've deployed this contract into localhost. And so we have this contract, and everything to do with the contract already showed up. So this contract has one variable called purpose and a function that allows you to set purpose. And as you can see, it automatically loads the contract and loads all the functions and variables for that contract. So you can directly interact with the contract in immediately with scaffold-eth-typescript. And if you want to change the contract, say you wanted to add purpose number 2, all you had to do is set it up. And I'm going to build my contracts by typing in yarn build, yarn contracts build. And then I'm going to deploy my contract. So you immediately have access to the new Solidity contract, and there's nothing you have to do. So this actually makes the development cycle really quick. I didn't set up a function for the second purpose, but for the first purpose, I can send a variable to that contract. And, oh, I don't have any cache on this. Set it up later. And I can interact with the contract. And another thing I wanted to show was in the main page, I have access to the contract reader and the purpose function. And because it's typed and it immediately builds your contract, you can have access to purpose 2 here as well. So I just call, so basically I'm getting, I'm calling this hook called use app contracts. I'm passing in the name of my contract, and I'm passing in the chain ID I wanted to connect it to, and I got the main contract. So I'm going to use this contract, and I have access to the purpose 2 function right here. So it's automatically generating a typed variable for your contract, so you can directly access your contract and use it in your React app. And so I can use contract reader to get access to the data now we have access to your second purpose, and you can use it anywhere in your app. So this is all part of the context system as well. This is part of the use app contracts hook and the context. So let's see. We're going to create a new page, and then I'm going to show you how to access contracts in a brand new page, so it's a little easier to see. So I'll create a little component called yeah. So I'm going to create a new component. I'll call it your contract. So this component is going to be a new tab in the main page. Maybe this is not a good idea. So let's step back a little. I think I need to show you guys how the ethers app context works. So in the app, you're going to wrap your main app with ethers app context. So this gives you access to this gives you access to the context anywhere in your app, so you can use it anywhere in your app. So as I mentioned before, we use this hook called use ethers context to get the ethers context, and we can use that anywhere in the app in addition to any hooks that you want, to get access to what the provider that the user is logged into currently. So for example, I'm going to log out and I'm logged into Matic. So this ethers context now will have access to the Matic network and the user, the signer, the provider, and everything you need to interact with that user on the Matic network. So with that, you can actually call any of these functions: use balance, use block number, use signer, address with the ethers context to get that data from the provider and from the hooks. Another important thing with this system is that you can also do that with contracts. So I've already mentioned that you have your contracts are part of the scaffold-eth setup. So anytime you make changes to your contracts and you build a contract, it'll automatically push that into the app and you have access to those types. And how that works is that there is an app config, contracts connector config. And what you're doing here is that you're telling it that there is your contract, and you're telling it to create a connector for the hard hat. So this is automatically going to load your contract app anywhere, and you have access to it anywhere in your app. So in the main page, I have these helper hooks that you want to call in your app. This use load app contracts will load all the contracts for you, and use connect app contracts is going to connect them to the network that you want them to connect to. So in here, I'm connecting it to the network that the user is currently signed into. That's the ethers context. So this app is automatically connected through the web3 context to whatever network that the user is signed into. So I'm going to go back to localhost. And as you can see, because I've deployed it into localhost, you have access to the contracts in localhost. And that's pretty much it. If you want to, that's how you would connect to any contract in your app. And you can easily add new contracts in the same way. So if I create a new contract called your contract, my new contract, I'm going to create a deploy script for it. So in order to deploy that contract now, all I have to do is run yarn contracts build. It'll automatically generate all the types that you need to interact with that contract. And So now all I have to do is use my new contract, and I'm gonna copy this. Oops. It's not working. Let us see. I think it's not deployed. For whatever reason, it's not working. So I'm going to move on to the next feature, and then we'll see. I'll look into this later. The other option it also allows scaffold-eth-typescript allows you to do is to load external contracts. So I'm going to comment this out. And there is this configuration called external contract config. And how this works is that you're going to have to pass in the name of the contract and the address the contract is located in either mainnet or Polygon or whatever network you're at. And it's going to, when you run yarn contracts build, it'll automatically fetch that contract and their the contract's APIs from the network, and then create the types that you need for that contract. So if I wanted to use the DAI contract here, right here, what I'm doing is I'm calling use app contracts. I'm passing in, and these are all types. So I can pass in, right now I have 3 different contracts. I can pass in DAI, Uni, or your contract. So I'm passing in DAI, and I'm telling it to connect to the mainnet chain ID. And I have access to the DAI contract. So anywhere in my app, I can access any of the DAI functions. So for example, allowance, balance, purpose, and I can use the hook I can use a hook called use contract reader and pass in DAI. So for example, in the DAI contract, I can call allowance. And I would have access to the value of allowance in my use contract reader, or I could have access to balance or any of these other variables. And I can call any of these other variables and get their output. So this is available to you through the contract context anywhere in your app. So that's a good overview that's a very quick overview of scaffold-eth-typescript and how the contracts context and ethers context works. I'll probably make videos out of this. It's kind of hard to have a presentation about it, and I'll go into more details about it. One thing I wanted to show you guys was that there is a website that has a quick start guide and common examples of how to use the hooks and how to use scaffold-eth-typescript and how to set up your providers. There is also an API guide on how all the different hooks work. We have about 15 different hooks for balances, getting the block number, loading contracts, using contracts, getting the gas prices. And we'll have more documents on deep dives and how the design principle works. So check out the scaffold-eth GitHub docs. And then another thing I wanted to bring into attention is as part of the Build Guild, we also have this onboarding website called Speedrun Ethereum. And in Speedrun Ethereum, you can run through different challenges that give you an overview of how different aspects and different contracts in Ethereum work. You can do requests, and you'll have access to the JavaScript and also the TypeScript challenges, and it'll show you how eth-hooks for and scaffold-eth-typescript work. Feel free to check it out and get an overview of how the Ethereum network works and how you can connect to NFTs and how you can create NFTs, how you can create a decentralized staking app or a token vendor. So all of them have JavaScript and TypeScript examples. I guess that's it. To wrap up, that's an overview of eth-hooks and scaffold-eth-typescript. One of the other libraries that we also use in scaffold-eth and scaffold-eth-typescript is eth-components. It's a library of components that use Ant and eth-hooks to make it easy to develop scaffold Ethereum apps. It gives you like this contract component. It also gives you access to addresses, components to log in and log out, gas price. So check that out as well. One of the things that we're looking into is to, in the near future, creating a headless version of these component libraries and also creating a Tailwind library. So look forward to that in the next few months. I guess that's it, guys. Oh, there are some questions. How would I set this up with something like Redux or GraphQL? So Redux and GraphQL are basically, you can easily use Redux with this. Right now, the ethers context will use the context. If you want to pass that information to Redux, you probably just have to pass the whole context information into Redux, and you can do that manually. But I think that it doesn't need to, they don't need to both be part of the same state. It doesn't make a lot of sense for them to be part of the same state. So I personally would use Redux for your application state and client state, and I wouldn't use that for the network state. I would just use the context for the network state. It's kind of a good practice to separate application state and server state. And I would consider Ethereum data to be like the Ethereum network, or as a server that you're connecting to an Ethereum network state. So you probably don't want to store that in Redux. I guess that's it. If you guys have no more other questions, check out my videos on how to create eth-hooks and how to use eth-hooks, and we'll probably create more in the future. Thank you so much. Really appreciate it.